So one of the big common mistakes that people make with a GCF is when they identify the variable or in the coefficient part. The coefficient part here was just 1. So that's your number part. And then the variable part is x, and the lowest power is 3. Okay, so we do all that work right, get our GCF is x to the third. So what we need to do is make sure that we're not pulling it out, but dividing it out. So our GCF is x to the third, and you write parentheses, and then you've actually got to do division. Typically, the wrong answer that people are coming up with is we're writing x to the third, and then we pull it out, and we get negative x y to the 4. And so we sort of do the process, but we don't do it completely. We're pulling out instead of dividing it out. So what we need to do is divide each term by x to the third. And if we do that, we'll see x to the third divided by x to the third is 1, because anything divided by itself is 1. And then the second part was negative x to the fourth divided by x to the third. That should reduce to be a negative x to the first, and that's when we get the y to the fourth. So this should be a 1 minus x y to the fourth. You've got to have that quotient to make the 1 appear. So that's one of my most common mistakes. So the second most common error that people make when they're doing the GCF is they're not finding the greatest common factor. They go for a CF, a common factor. And so we look at something like 48 and 36, and our eyes see that, say, 4 goes in to both. And so we say, okay, my number part was 4. And then we might even come up with the right variable parts. And the variables, we've got x, the lowest one is 4, and then there's no other variables. The y and the z don't overlap. So then they divide, and we get your product, your basically it's a common factor, not a greatest common factor, of 4x to the 4, and you would have 4x to the 4 on the outside, and then you try to successfully divide. And your division will be successful, it just won't be completely factored. So we divide here by 4x to the 4, and we get 12y, I meant to say, and then divide here by 4x to the fourth, and the 36 divided by 4 will get to a 9x squared z to the third. And what you'll recognize, and you'll know that this problem isn't completely factored, because if we're looking at our binomial here at the end, the 12 and the 9 have a common factor. So it's not that you did something wrong, you just didn't do it completely. So you could keep going. If you ever recognize that your coefficients have something in common, you just have to go another step. And so the step is that these have a 3 in common. So you have to recognize another 3 needs to come out. So you leave the 4x to the fourth right there, and then you factor again with a 3. So you say times 3 times, and then you've got to divide each of these by 3. So you can see how it got a little bit more tricky here. Divide this by 3, and that's going to give me y, which it should have had. And then divide this by 3, and that's going to give me plus 3x squared z to the third. Now this is factored completely, but I should go ahead and take my 4 and 3 out in front and multiply before I submit. This is technically correct, and it is factored all the way. It's just that we usually go ahead and multiply our 4 and 3 to get 12x to the fourth, and then left over would be y plus 3x squared z to the third. Now, it would have been best had I recognized at the beginning that 12 went into 48 and 36 as my greatest common factor, not 4, 12. And that would have made this process a lot simpler and one step instead of 2 steps, where the second step was much more tricky.